So we're going to learn about parametric equations right now, and basically parametric equations are still like typical equations on the function of the graph, so we can still have x and y, or x squared and y squared. However, in this case, we don't represent x and y in one equation. We use two equations. So we have two equations. And what I mean here is we use a third variable to represent both of these equations. So for example, I had y is equal to, we can say 2t. So t is just another variable, and we can just plug values in for t, but t is not plotted on the graph. We only plot x and y. So x is, let's say we can say t squared minus 5, right? So there are two equations that one stands for y, one stands for x, and they tell us how we can plot the graph. So if we're going to plot the graph, we make a table. So we say, when I plug in, so I plug in t, so what do I get for x and y? So I just make a table like that, and then I plot all my points. So in this case, x and y are independent. They're not related to each other like we have y equals x squared. So in this case, we have parametric equations. There are two equations that represent x and y coordinates separately without relating them to one another. And we represent these two equations, so we write these two equations using a third variable. So t here is just a random variable that we're going to use. We're going to plug the values of this in, but we're not going to plot t. So let's just try putting this set of equations to see what parametric equations look like when we actually plot them. So I draw my Cartesian coordinate plane, and basically this is my origin. Okay, so if I plug t equals 0, then y is 0. Okay, so it's 2 times 0 is 0, right? So y is 0, and then x is 0 minus 5, which is negative 5. So when t is 0, I have x is negative 5. So let's just plot that point there. So then when t is 1, I have my y is 2. Y is 2. 2 times 1 is 2. X is negative 4. So 1 minus 5 is negative 4. So my negative 4 and also 2. So this is my point here. And then when let's try bigger values. So let's say when x is equal to 3. So actually no, when t is equal to 3. So when t is equal to 3, x is gonna be 3 squared, which is 9, minus 5, which is 4. And then we have y is 2 times 3, which is 6. So we have the point 4, 6. So let's try another equation now. So we have, let's try another graph now. So let's say we had t is negative. So what happens when t is negative? I want to try negative 3. So when we have negative 3, y is negative 6, and x is negative 3 squared, which is 9 minus 5, which is 4. So when t is negative 3, we plot 4 and negative 6. So this is 4, and negative 6 is down here. So we have a point. So this is starting to look something like a parabola that's opening to the right. And in fact, you're going to ask, isn't a parabola relating x and y values together? Well, indeed, we can relate these two values together. So given this set of equations, we can actually solve one of the equations in terms of t. So we can solve, let's say we solve the one of x in terms of t. So we only have t squared minus 5 is equal to x. So t squared is equal to x plus 5. So we know that t is actually just, you can say it's plus minus root x plus 5, right? So yeah, plus minus root x plus 5, and you plug that into the y equation, and you have plus minus 2 root x plus 5. So we just square both sides. You can get rid of the plus minus sign. You have y squared is equal to 4x plus 5. If you expand that, it gives you 4x plus it gives you 4x plus 20. And this is obviously an equation of a parabola that opens towards the right, right? So basically, this explains why and how we can relate our parametric equations with x and y represented by a third variable together. So we write one equation, we used one equation, we write t in terms of that equation, we plug t, the value of t in that equation, into the other equation, and we solve for it. So this is how we plot parametric equations. We can try another example. So let's say I have the set of parametric equations. So to reinforce the concept, I'm going to say what they are again. So basically we have x and y represented with a third variable. So we can say, so this time we can say it's t, or we can say it's k this time, okay? So we're going to say it's k, and then we represent x and y with k. So x and y in this case are, well, sort of independent. So usually we have x equals y, or x squared equals 2y, etc., right? So now we have two equations representing x and y. So the progress of x and the progress of y are independent. You can regard them as independent. So they don't have any relationship. So basically, let's say we have x is 5k. And y is, I don't know, k squared minus 3. So let's do that. So we have, so before we draw the graph, we have a table here. So we have a lot of rows, and we have t, x, and y. So t, x, and y. And then now we can draw the Cartesian plane. So this is the y coordinate. This is the x coordinate. This is the origin. Let's start with, this is k. So this is k here, sorry, my bad. So basically, let's start with k is 0. So when k is 0, we have x is 0, and y is 0 minus 3, which is negative 3. So when k is 0, we have 0, negative 3 as our point. So that's one of our points. When k is 1, we have x is 5, y is 1 minus 3, which is negative 2. So we have 5 and negative 2, so this is our point. So what about negative values? Let's try negative 2 here. So when we have x is negative, so k is negative 2, we have x is negative 10, and y is negative 2 squared, which is 4 minus, so 4 minus 3 is 1. So y is 1, and x is negative 10. So let me just extend this graph a bit. So something like that, and then we can assume this is negative 10. So our graph here would look something like this. So the shape is not really clear. Now let's try another value. Let's have negative 1. So in negative 1, we have x is negative 5, and y is negative 2. So we have negative 5 and negative 2. So this graph here. So it seems like that we have a really, really, really wide parabola that's opening upwards, like that. Something like that. And it extends forever in both directions. So that looks like our graph there, right? So now we're gonna relate the two variables to x and y together to see why the graph is a really, really wide parabola in terms of how x and y associate with each other. So we write for one equation. Let's use the x equation. We write the equation in terms of k. So we divide both sides by 5, right? And we have k equals x over 5. So now we plug k in for the second equation. So we have y equals k squared, which is just x over 5 squared minus 3. So y is x squared over 25 minus 3. So this gives us our parabola, and as you can see, the coefficient here for the quadratic coefficient is 1 over 25, which is a really tiny coefficient, and it makes the parabola really, really wide. So that probably just explains why our parabola was so wide. So thanks for watching. Today we've learned about parametric equations. Parametric equations are where we represent graphs in the Cartesian coordinate plane with using two equations, one for x and one for y, and we use a third variable to relate the two equations, and we can also two equations are independent. We can plot x and y depending on using the parametric equations or the normal equations like this one, depending on which one is more convenient. So when we convert parametric equations into normal equations, what we do is we write k in terms of x or y, and then we plug the k into the other equation which we haven't used. So thanks for watching. Bye.